Hi, my name is Kellie Michelle Evans, and I'm a professor of mathematics at California State University, Northridge. I'm coming to you live from home because it is the end of, or hopefully toward the end of a pandemic. Um, and it's really helped me to have GeoGebra during these difficult times.
I started using GeoGebra for a class that is for math majors preparing to become high school teachers. And for this purpose, it's really great because you can actually post demos and have students interact with them during and outside of class. So have them think about, well, what about the circle that circumscribes the triangle? How is that related? Are there any other relationships? So, for example, what's the diameter of that circle, and how is that diameter related to these ratios? So I can ask my students, are these two triangles similar? Are they congruent? And then have them, if they are, have them find a sequence of rigid motions. So GeoGebra has reflections, rotations, translations, and dilations. So a sequence of those rigid motions and dilations that maps one to the other. So for this kind of thing in the past, it was a little tricky, especially on Zoom. So we're coming out of a pandemic. We've been teaching online for a year. So I can ask students if they're doing it, but I can't really tell if they are. So now GeoGebra has this really great feature, create class. So I can actually post this and then I could have them work on it and then I can see each screen. So then I can tell right away if they all get it and we can move on or if we need to work on it. So to see what this looks like from the teacher's perspective, when you have start a live class, then you can see each student's work. You can see their desktop. It usually shows their name, but you can hide it to make it anonymous for a video like this to keep their privacy. And then you can get an idea if people are working on it. You can see that some people may not have started it, but it gives you a really good indication of what's happening. So one very powerful thing about GeoGebra is it has all of these built-in commands. And so there's a list of these commands on this wiki GeoGebra. So GeoGebra will also do work with matrices. So I just typed in this matrix M1 and this matrix M2. So I'm going to ask for the determinant. So I just type in the word determinant and GeoGebra will show me, there it is. And so I found the determinant of M1, and then I'm going to ask for the determinant of M2, but GeoGebra is going to give me a question mark because you can't take a determinant of a matrix that doesn't have the same number of rows and columns. I'm also going to ask it to do reduced row echelon form. And you see that that's the reduced row echelon form of our matrix M1. And then we're going to do the same thing for M2. So my students greatly appreciated this in linear algebra because once they get the idea of reduced row echelon form, it's very tedious to do it for larger. So for example, this is a standard normal. And what you're seeing here is the area under the curve. And here it is for different values of X. And you can see that those are the probabilities that the standard normal is less than or equal to that value. It will also do straight edge and compass constructions. It has a compass built in. So here's an example where you start out with a segment of length 1 and you construct regular hexagons. So this is the probability mass function for a binomial that has parameters n and p. We're supposed to move these sliders so that this line in black best fits the data. So we can just experiment and eyeball it and sort of see where do we think it's best fit. So we're going to minimize the squares of the residuals so we can actually show those. And then we can get, it's easier sort of to eyeball it when we can actually see the areas that we're trying to minimize. That's why it's called least squares. And then we can compare what we got to the actual answer and we could see we're pretty close. Once you start using GeoGebra, you realize it's useful for almost every class. So this is how you can get started right away. Go to geogebra.org and I'm going to show you how to open GeoGebra Classic. All of them are almost the same idea. So once you understand how to use it in one setting, you can use it in others. So immediately you see there's a set of interactive XY axes. You can use these drop-down menus to experiment. You can zoom in, you can zoom out, and I highly recommend that you just experiment. So I'm just going to show you how you could graph any function. So let's just do a quadratic to make it simple. But again, you can make this as complicated or as simple as you want. Because GeoGebra didn't have A, B, and C, it automatically makes these default sliders. And so we can experiment to see what do the different sliders do to the actual So right quadratic. Now it's in English. You could change it to any of these many, many, many languages.
And I'm happy to tell you about GeoGebra.